मथुरा लीला मथुरा युक्तं मधुरं मुक्तं मधुरं दृष्टं मधुरं श्रेष्ठं मधुरं मधुराधिपते अखिलं मधुरं गोपा मथुरा गावो मधुरा यष्टिर्मधुरा सृष्टिर्मधुरा दलितं मधुरं फलितं मधुरं मधुराधिपते अखिलं मधुरम्. Today's quote from Swami Vivekananda. Swami Vivekananda said, "We are responsible for what we are and whatever we wish ourselves to be. We have the power to make ourselves. If what we are now has been the result of our own past actions, it certainly follows that whatever we wish to be in future can be produced by our present actions. So we have to know how to act." Thank you.
Thank you so much, Susri Prajna Rao. Now I would request Professor Chittaranjan Nayak from Guru Ghasidas Vishwavidyalaya and also organizing secretary of this Swami Vivekananda Loka Sansad to enlighten us about this workshop and also for the welcome address. Please, Professor Nayak.
Thank you, Chinmay, the organizer of today's National Workshop on Data Analysis. My esteemed friend, Dr. Pabitra, the resource person of today, I will speak about him. So at the outset, I say good morning to all of you. So this is really a wonderful experience that we are continuously engaged in updating ourselves, enhancing our skills, which will be useful in our research and publication aspects. Friends, uh, this is, I think, 14th or 15th in the series. Several national workshops, seminars have been organized by this Moga Education Council, which is a constituent wing of Moga Trust. That itself is a part of Swami Vivekananda Loka Sansad, an Odisha-based organization which is dedicated to realize the visionary ideals of Swami Vivekananda. Moga has actually four components. One is education, another is health, the other two are empowerment and environment. So the education wing, that is Moga Education Council, has been organizing such events on the first Sunday of every month. But when there are 4 Sundays, second Sunday is chosen, that is today. And so many events have been organized, especially on research methodology, targeting our young research scholars. And the learned experts like Dr. Pabitra have joined and enlightened young and budding scholars in this field. We know how important is social science research and how difficult is it to structure a problem, to visualize something, to analyze something, and we used to handle data to come for our conclusion, and data cleaning and data, organizing, then filtering and analyzing data uh, that has several inherent issues. And unless we handle data well, then our research conclusion will be fallacious, will be challenged. So, keeping in view that sort of those sort of challenges in mind, this specific workshop is being organized. And I am happy to welcome you all. And on behalf of all the participants and on behalf of the organization, this is my privilege to introduce and welcome the resource person of the day, uh, Dr. Pabitra Kumar Jena. Dr. Pabitra is working as assistant professor in Sri Mata Vaishnav Devi University, Bhadrak, in Jammu. And he has a lot to his credit. He has published 5 books and about 70 research papers in journals of national and international repute. He has organized several workshops, several faculty development programs, and conferences. Chinmoy is here. I am. Um, I also got the opportunity to join his university, participate in some events. That was, if I remember correctly, that was the event organized by the Indian Econometric Society, and he was the organizing secretary. So he is well known in the circle of economics across the country. So he has trained in such programs more than 800 faculty members, 600 research scholars in his training programs. So a lot many things. And his expertise is basically in applied econometrics, time series analysis. He has expertise in handling softwares like R, economic modeling, all these kind of things are there. So it is a nice opportunity to have him as our expert and resource person for the day. So without taking further time, I once again welcome my dear friend Pabitra to, to enlighten all of you with his experience and with his expertise and illustrations. So it is over to you, Pavitra. You have enough time, and the schedule was communicated to you. So when there will be questions, the participants can use the chat box, and if you are asked to unmute, then only to unmute. Otherwise, you can raise your hands only. But all should remain in mute. That is the minimum expectation from all the participants. But we should be busy in the chat box to give feedbacks, to ask questions to the resource person. And my request will be to the resource person that while explaining or while illustrating, please have a look on the chat box. If there is any matter of significance and that should be addressed immediately, it is up to you to decide. So, welcome, sir. On behalf of this organization, I extend my warm welcome. I think this is the first one to be witnessed from you, to be invited from you. So, warm welcome again. So, please over to Dr. Pavitra.
Thank you, Professor Chittaranjan Naik, and for us, it's Chitta sir. So, um, thank you for your kind words. That whatever you told, that it's that some briefs, brief profile about me. But I feel I'm a student. Every day I learn. So I was also student like all these people who are attending, but since I am working in this area and every day something I'm learning, so still I consider as a student and still I'm learning. And so today I expect I will also learn so many things from this interaction. So first of all, I would like to tell that I don't want to make this lecture as a one-way traffic. So you are always welcome to ask the questions. Anything that what I'm teaching, you can use the chat box, so we can have a dialogue. And in fact, after like 1 hour lecture, we have half an hour there we can discuss. So before starting that, since the data analysis is the big area, so you need the series of lecture. So like 1 hour, 1.5 hours is nothing. So for me, the challenging task is that first I need to understand my audience, what type of audience I have. So in my chat box, I would like to know that how many student is from non-economics background, non-economics and finance background. How many students are from non-economics and non-finance background? Can just raise your hand. So 35, just 1 minute. Okay, it's near about 40. So Chito sir, it is like, for me, it is like challenging that if I straightforward jumped into the data, like data and types data and time series, I start like I understand some students are like research scholar. If I start teaching from what is data presentation, data tabulations, and the basics, statistics, and all this, then these student who are like research scholar, they will feel bored. So what I should do? That directly I should go that what the data analysis time series, then little bit like how you are suggesting how I should go about it. Chitra sir, am I audible? Am I audible to everybody?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay,
Yes,
you
sir.
can also give your feedback. Like, what is your expectation? Like, I can deliver lecture like in a minimum level or higher level side. Like, straightforward, I can go to the data and how to handle the data, like time series or panel or cross-sectional data. Or should I start from what is data and how we should, like, from for a layman, how should I go for
Yes, sir.
data?
So start from the basics so that we can also revise it, and those who don't understand, they can learn it.
Okay, so what I am doing, so for basic, like I'm just starting from basic, and the basic part I will just go through within 30, like 15 to 20 minutes. Then I'll jump to like data analysis, like how a researcher should address a data. Okay, I think that will be the fair, good way to tackle. Okay, thank you. Because a lot of students are telling, sir, please start with the basic. So I should start with the basic, because I can see some of the students who are economic student and doing PhD. So for them it may be a basic, but please 10-15 minutes, please try to brush up your knowledge. Then it will be good to us to catch the that momentum. Okay, thank you. So with this, I am just sharing my slide. I think my PPT is visible to everybody.
Yes, sir.
Is my PPT?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
We are able to.
Yes, sir. So the title of the today presentation is Data Analysis in Social Science Research. So before like data analysis in social science research, so you should know what is the definition of like data, or like basically the statistics. So in the general sense, it refers to the facts and figure. So in statistics, in statistics as a science, it is a collection, organization, presentation, analysis, and interpretation of numerical data. So only when you get the data, you need to know the understand actually how you should actually organize all this, like what are the process of tackling this, actually tackling this data. So in a statistic, there are 5 steps through which actually you tackle the data. First is collections, second is organizations, then third is presentation, so fourth is analysis, and fifth is interpretation of the data. So before starting that telling, so in a simple sense, data is the collection of facts and figure. Okay, so it is a random process. So in a random process, in a time series language, it's a stochastic process. So what happens from a empirical point of analysis is from point of view, data, the type of data is divided into 3 types. One is cross-sectional data, second one is time series data, third one is panel data. So in cross-sectional data, as you know that maximum students, they have already have knowledge about the cross-sectional data. When you collect data in a particular period of time, like today I'm collecting data regarding the what is the view regarding the quality of a restaurant. For example, when you are going to dine in restaurant, so there's a lot of expectation from the restaurant, like hygienic, food quality, uh, price, and all these things. So if some survey you'll do that, and that a particular time, and you try to collect the data from a different dimensions, so that become the cross sectional data at a particular time. It's like one day or any day of a year. So that is known as cross-sectional data. The second one is time series data. As the name suggests, it has a time elements are involved there. So it's an interval is there. So from a particular time to a particular time is known as time series. For example, if you collect the data like macroeconomic data, when you collect like GDP data from 1950 to 2020, that become a time series data. You have a time from 1950 to 2023. You have 74 years data is there. That is known as time series data. And when you combine this cross-sectional data and time series data, that become a panel data. So for example, in panel data, you are able to capture more characteristic of heterogeneity. For example, if you have in a banking sector, if you want to know what are the advantage, what are the factors that are determining the performance of a bank. So overall, if you do a time series analysis data, so you will get like rate of interest, then online facility, and then you have that way of dealing the customer. There's a lot of factors will come. What are the factors for performance of a bank? But if you want to know if there are different banks are there, like 20 banks are there or 40 banks are there, and after that also you have a foreign banks, you have a private banks, you have a regional banks, how these banks are different from each other, like how they are heterogeneous. If you want to capture that type of behavior, so you need a panel data. Like in the same story, it goes for a cross-sectional cross states analysis. Like if you want to know what are the determinant of a GDP or in a like macroeconomic level, so there all the state data are actually combined. But if you want to do the state-wise analysis, the same data you segregated state-wise and try to understand how the different state, like it is that heterogeneity is coming out. So that is like cross state. Like also in the global level, if you want to do cross country analysis, like how India is different from China, how China is different from USA, how USA is different from Japan, like same macroeconomic data like GDP, inflation, money supply, interest rate, foreign exchange reserve, same data you take and you try global level. If you will take like one figure you take. But if you take 10 countries and trying to do the cross analysis, you will get different countries. So here you have a time series. Like again, panel data, they are different different type of the balance panel is there, unbalanced panel is there. So in balance panel, you have that same like data is repeated and all the data is available. In unbalanced panel, what happens in some of the time that your data is missing. Okay, so like if for like I'm giving example for 1950 to like 2023, if you take data for India, Japan, USA, UK for 5 different variables like GDP, inflation, money supply, foreign exchange reserve, and interest rate. So that means for each country, that for all these 5 variables, it will repeat again and again. So that in what like in 74 row, first you will keep data for India, again another 74 row data for the Japan, again below another 74 row. So your degree of freedom will increase here. So your analysis will be robust. So before telling that like type of why I'm telling this, because before understanding data, you should have fair idea what types of data is there. Once you know the data, then you can go for presentation, tabulation, whatever you want to do that. Okay. So the simple actually aim of the statistics is that to present data in a definite form. So actually what it does is simplify the mass figure, and also it do the comparison. Why is it do the comparison? If I'll give a like a 10,000 figure, and if I'll not give in a systematic way from the 10,000 figure or 200 figure, can you give some conclusion from that? No, you cannot give any conclusion. So if I tell you give like if I'm giving this data, you give some summary, at least any form of summary you can give, like mean, media, whatever you know. So that will give a fair idea about what this data is telling, how the trend, like even if you don't give anything and you plot one figure through the like in graphs, from the trend analysis itself you can understand how the data is behaving. So it helps in like formulating. So the next step for empirical analysis, like data helps us testing the hypothesis, like that we'll discuss. Like I think some of the students already they know what is hypothesis. Like when you take data and you try to try to compare any, try to prove any theory, you need to take hypothesis, and data helps to actually testing the hypothesis. So also data helps for predictions. Like if you have a GDP figures of say 78 years figure, and with that you want to predict or forecast for the future, it helps to actually predict for the future. So also in for a policy point of view, it's help for formulation of suitable policy. Okay. So also I also want to tell that the source of data, you have two source of data, that is primary source of data and secondary source of data. So the primary source of data, just I'm telling that there are different types of primary source of data, but please try to understand the primary source of data, where data is collected by investigator itself through his personal contact or by appointing somebody. Then primary source, the data is divided into different type: direct personal investigation, indirect personal investigation, investigation through correspondence, investigation through questionnaire. So different type of is there. Time required to explain what are the source on all these things. So, but for time being, understand for primary sources, that statistical investigator actually collecting is the involved for data collection. By directly he can go and collect, since he does, if the study will be small, he can go and he can sit in front of the the interviewer and ask the question. But if it's a big data, a big field, then he can append some of the like research assistant, and he can give the questionnaire. They can go, they can collect, or they can throw that, they can send that questionnaire through email. Also they can collect. But secondary data source is a very simple source of data collection that people like us, who when you do macroeconomic modeling, and we have data is stored in a particular website or from one agency, we collect data and try to process it. That is the secondary source of data. And for economy student, for like Indian economic data, Reserve Bank of India or CSO, Central Statistical Organizations, is give the maximum data. Apart from that, you have DIPP is there, Department of Industrial Policy and Promotions. There are so many, like for health, educations, population, different like source of data is there. So that means when the data is already collected and stored in a particular website or by any agency, by individual, and you use that data again, that become the secondary sources. I think that your types and source of data is clear now. So then the next step happens, that when you got the data, how you do that. So the first step is you edit that, then classify, then you tabulations. So first, and that question is that when you get the data, what do you do with that data? So first, with the help of diagrams or graphs, you try to see the trend, how the data is moving. Because in the time series analysis, I'm talking about time series because I do for a student or finance students, time series that analysis maximum time you do. So first, what do we do? The graphical, we do the graphical presentation to know what is the trend of data? Is it like whether any special treatment is required or not? Okay. So that part, that special treatment part, I'll go to the that when I'll start with the data analysis. For the time being, I'm giving one pause there. So for basic, yeah, somebody is telling something. Some sound is coming. Can you mute? So for like simple data, so basic data analysis we can do through measure of central tendency, measure of dispersions, correlation, regression, and causality. Apart from that, there are n numbers of techniques are there which you use for doing the data analysis in social science. So why and the last discussion is that when you have all these techniques, by using all the techniques, when you get the data, so this I don't want to discuss one by one because it will take time. But the next step is interpretation of data. So when you interpret that, that you get the data through all these, like your whether first measure of central tendency, measure of dispersion or correlation or regression or causality or any other time series advanced techniques or panel data, then you need to interpret what from the result what is coming out. Whether then what the data we are, what that the interpretation of like result we are getting, is it meaningful or is it significant or is it not significant? If it's not significant, what is the reason? Okay, and that things you can only do that if your that data what you are using, that you have cleaned properly. Otherwise, if you are straightforward using the data and that you are doing interpretation, that is wrong. Okay. So I don't want to tell all this definition of table, and these are the part of the table, like part of the table number, title, caption, this all this you know that, and this is the frequency distribution. Just I want to skip that one. The second data analysis is okay. See, like from a empirical point of view, this data analysis is divided into three parts. One is univariate measures. Second is bivariate measure. Third is multivariate measure. So nowadays they are telling univariate data analysis, bivariate data analysis, and multivariate data analysis. So univariate data analysis means when one variable you are taking and trying to do some analysis, that is univariate data analysis. And bivariate means when you have a two variables and trying to do some analysis, that is known as bivariate. And multivariate is that when you have more than two variables and trying to establish an impact or causal relationship between the variables, that is known as multivariate data analysis. So there is a n number of techniques are available in time series as well as panel data, or in a cross-sectional data. So as you told like as I told that measure of central tendency, and that in measure of central tendency you have arithmetic mean, median, mode, geometric mean, harmonic mean. So when you take one variable and do like all these variables and you get all these figure, that is known as univariate analysis. So if I take GDP and try to find out all this, that value of all this arithmetic mean, median, mode, and GM and HM, this is known as univariate analysis. What I'll do, like I am trying to cover how much I can do that. See if the time will permit me. I will also do hands-on on Excel and hands-on on SPSS, and if or whatever you are comfortable, I will do that. But let me to do like theory how much I'm telling. Otherwise, in another class I will try to do like hands-on. Okay. So this is like a techniques of like what you call it univariate data analysis. I'm not going details on what type of the techniques are there. So then, and apart from like measure of central tendency, you have measure of dispersion also. So central tendency give a one figure to represent the entire data. Just I am trying to explain the what are the measure of center and tendency? It gives one figure which explain the entire data. So like median give the average figure, mean give the middle figure, and the mode give the highest figure of that distributions. So like that, measure of dispersion is trying to understand how data is scattered over a type, over a sample area. So there are different, like if like in a empirical analysis, in a like time series analysis, we use one one techniques repeatedly, that is standard deviations or standard deviation, that it shows how your data is actually scattered, or your data is how much is deviate from your mean variables. That is standard deviation. So this range, interquartile range, standard deviation variance actually explain the degree of variance or degree of dispersions or degree of scatteredness. All skewness, kurtosis also shows the same types of things, but it has a different meanings. How picked or how bulgy that figure it is. Okay. So this is all about measure of dispersions. Then we have actually bivariate and multivariate data analysis. In a bivariate and multivariate data analysis, you have correlations, regressions. So in a bivariate, you have correlation. You have, if you have two variables, we can find out what is the correlation between the variables. And the regression, if you have two at least one dependent variable, one independent variable, you can find out what is the impact between the two variables. And if you have more than one variables, you have one dependent variables and more than one independent variable, that is in one multiple regressions. Also, we can find out the impact analysis. So all these like correlations, types of correlations, that PPT I have, I will just share with you. Due to the paucity of time, I'm not explaining you, because I understand out of 200 students, 130 or 40 students, like they are in advanced level. So I'll start with that, like time series analysis, how you'll actually tackle that, all this data. So this is like according to me. So this basic I have covered. So now what I'll do, now I'll start with like time series analysis. Like now I'll talk about from a researcher point of view, like how when a researcher gets data, how he should proceed. Am I audible?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So
Yes,
is this much of basic is clear? So before starting.
Yes, sir. Yes, sir.
Okay. So I'll tell, like for example, when you complete your master degree and you enrolled any PhD program, and basically in the first step you struggle with what I should do. That generally you do one like research proposal and try to find explain your objectives and all these things. And people who actually do the whether the primary data or secondary data, so you need to handle the data. Okay, whether the primary and secondary, primary is different and secondary is different. And basically I work in the secondary data, and nowadays also I'm started learning how to do handle primary data also. Some of the paper I've already started and I have already published, but my core analysis is on like secondary data analysis, that is time series. I was doing, now I'm doing in panel data. So let's discuss, like as a economy student or finance student or any other student, if you want to do the macroeconomic analysis, or you want to do an, yes.
Sir, I have a query. I would request you if you can say something about independent and dependent variable and the control variable part. So I
Okay.
will be obliged to you.
Okay, so actually when you take like in a regressions analysis, you have two types of variable is there. One is dependent variable, another is independent variable or independence variables. When you have more than one independent variable, that is known as independent variable. So if I'll talk about like mathematical point of views, y equal to alpha plus beta x plus ut. Okay, so here a equal to intercept, b equal to beta, and beta equal nothing but is a tan theta equal to p by b. That is perpendicular by base. Okay, so this what this like slope shows. The slope says the rate of change in dependent variable due to change in the independent variables. Like if you have, like if I'll take the simple example of the like a Keynesian consumption functions, you have a consumption function in dependent variable and income in the independent variable. That means when your income changes, how the consumption is going to change. Like when you 100 rupees your income changes, how much like your how much like when income changes, how much consumption is going to change. Like your income changes 100 rupees and consumption changes 80 rupees. That means your beta equal to 0.80. That means 80, it is 80%. Okay, so but in some analysis, like not only like consumption is a function of like income. Apart from that income, you have different like you variables which also affect the consumption functions, which is known as extended consumption function. Like you have wealth, you have a like rate of interest, you have like health expenditure, you have education expenditure. Like not only consumption depend upon your income. Like in a certain year, like if you have health expenditure, God forbid that should not happen. If somebody falls sick, that your health expenditure increases. So when your health expenditure increases, so your consumption decreases. Or in education expenditure increases, your consumption also decreases. Or if you take home loan for construction of a home, then your consumption decreases. So not only in isolation that when your income increases, consumption increases, there are actually other factors are available. And that other factors is known as control variable. What question you have asked, that is known as control variable. For example, if I want to understand how this growth is affected by like FDI, foreign direct investment, if I do an analysis and try to do the analysis between growth and FDI, that I am going to do the specification bias mistakes. So like I cannot run in a macroeconomic modeling, I cannot run a regression by using dependent and independent variable, only one variables. So I need to take some control variables which are actually also they have some influence on the growth. Apart from FDI, I can take investment, I can take repo rate, I can take interest rate, I can take foreign exchange reserve, I can take inflations. So that's why you'll see that in a paper, some of the research paper, it is written the dynamic relationship between growth, foreign exchange reserve, or inflations. But if you go for when you go in the if you go to the like paper, that core analysis paper, you will not get three variables. You will get more than 10-15 variables. So that is considered as a control variables. That this variable is required because it has actually some impact. If you will not include that, so you create specification bias. What is that specification bias? You have not included what are the necessary variables. That means if you that will do, so you will actually commit the multicollinearity problem. I think I have explained what is control variables. Did I created make any sense? Yes, madam. Am I audible? Is it clear to you?
Yes, sir.
What is dependent variable? What is independent variable? What is control variable?
Yes, sir.
In a very simple sense, dependent variable is that when you change something, it has impact on other variables. That is actually dependent variable. And control variable, I told why you take control variables. Okay. Okay. Having said that, so we'll go for like as a researcher when he try to do if I'll give some macroeconomic data, so he or she cannot actually do the analysis straightforward, cannot do the analysis that data analysis. Before that, he or she should understand how he should actually proceed with that data. Okay, like for a primary data, you should understand that for primary data analysis, you should do that your reliability test and validity test. Without reliability test and validity test, if you are doing the primary data analysis, that is wrong. Reliability test you can do Cronbach alpha. Like that in time series data, when you are getting the time series data, you have to check the stationarity. So in a very layman language, stationarity means that you need to check that whether your data is normal or not. If your data is not normal and there is some outlier, and if we are doing the time series analysis and using any bivariate techniques or multivariate techniques, that regression will be spurious regressions. Okay, or what we call it a nonsense regressions. So if you have done everything in a very scientific or systematic manner, so and when you do interpretation and give the policy suggestions, so that is actually expected in the policy forums or any when you give, and if you submit in forms of dissertation report or thesis format. So that is the understanding why we do data cleaning and stationary test. So before doing that, you should understand what is like time series. I have already told the time series is the example of stochastic process. So the stochastic process is nothing, it's a collection of random variables. So like when you throw one, like when you play the Ludo, so you throw that Ludo again and again. So like 6 times, like you throw 10 times, you will get the 10 different numbers. So that is known as random variables. So that probability of occurring 1 to 6 has equal chance in every throw. So in a random or time series novel, it's like a random number. So with the passage of time, so you get on random figures. And in a data analysis, they're telling this random figure should actually follow one trend. So that's why the stationary test is required. So in a stochastic process, in a technical language, and in a time series data should be stationary if equal the mean equal to constant, variance equal to constant, and covariance are independent from the time lags. Okay, what are the three minimum assumption of the stationary? That variance like mean, expectation of u equal to 0, expectation of u square equal to expectation of u equal to constant. Like if equal to 0, then it will be white noise. So expectation of u equal to 0, expectation of u square expectation of u equal to constant, expectation of u square equals to constant, and covariance of ut and ut minus 1 should not equal to 0. So that means there should not be any correlation between the two time lags. So for a layman point of view, what this stationarity is there? Stationarity means when you plot data in a like a simple what you call line bar or histograph or line any graphical presentations. If there is a wide ups and downs, that data we cannot use for time series analysis. Please try to understand why. Because that is outliers. Like if there is a sudden off and after some time there is a sudden down, so that data we cannot use. So that is considered in a time series, that is considered as outlier. Is it clear? Why? Like if you everybody know there is a global financial crisis. So in a one day, the stock market from the 17,000 crashed to the 7,000. So this type of behavior cannot be actually measured in the time series analysis. If it would have been like correct that there are a lot of financial analysis, there are a lot of forecasters, there are a lot of economists there. Why they could not forecast? that stock market is going to behave like this, and one day it is going to crash like this, because also in the stock market we forecast, also in inflation we forecast, also in the GDP or SDP also forecast. Why could not they do that? Because this type of non-linear behavior you cannot forecast. Okay, so if you are forecasting, then what I told you will get spurious and nonsense regressions. I am giving one simple example. If some of my research scholars, I know some of my research scholars I known to, like Chinmay, he was like my research scholar. Anytime whenever I visit Odisha, he says he see and stay, sir, namaskar, and all these things. So this is a normal behavior from a research scholar. If one day he will see in the road and give a big slap to me, can I expect this type of relation behavior from him? That is called abnormal behavior. That is called sudden change in the behavior. Like that, either Chinmay behavior, like when everybody every day or every time when I see and he give regards to me, and one day suddenly he is giving a big slap to me. Can I expect that type of non-linear abnormal behavior in him? And if I feel this type of abnormal behavior on him, so I cannot forecast that in my next day when I'll see anybody that he can do that anything to me. Like that, if the data behave like that, so you cannot forecast and you cannot do any empirical impact analysis. Are you getting why stationary analysis is required? This awkward example I've given, you should understand why this stationary test is required. Am I making any sense? Am I audible?
Yes, sir.
Is it the correct way to move? Or if you have any doubt, you can ask me. So that's why I told you from very beginning, I don't want to make this lecture like 1 hour for 30 minutes, 90 minutes lecture in 1 hour traffic. You should ask the questions in between if I'm not getting it. Okay. Okay, so the next step is that once you understand why stationarity is required, that how to...
Excuse me, sir.
Yes, please.
Can you just repeat this again, like the stationary test?
So from the mathematical language you want to understand, or like from a layman language you want to understand what is stationary?
I mean, I think any language is fine as long as the sense is conveyed.
Yeah, for a layman language, like if just I'm going just one, that figure is not coming somewhere. That figure was there. I think some other site it is there. Anyway. Just one. Like when you have its data, like if I give the simple data of inflations, that inflation data is available. You are from which background? Finance, economics, or any other background? Yes, madam. Actually, I cannot see because I am just seeing my slide. So please tell you are from. But I can give example from your discipline. You can understand better. For example, if you are from economics area, if I give the inflation data, weekly inflation data is available. So you have to, for like I'm giving for 100 weeks or 120 weeks, you have to just plot any types of graphical figures. You can just line in a line plot. You do that line plot. Okay. How this data is moving from a graphical point of view, you can understand if there is a lot of huge frustration is there, or what we call fluctuation is there, or volatility is there. We cannot actually use the data directly. We need to do the data stationary, and that what is the stationary is that I told there is a 3 simple assumption or properties of stationary is there. Mean equal to constant, variance equal to constant, and covariance is independent from the time lag. Or in the mathematical term, expectation of ut equal constant, expectation of ut square equal to constant, and expectation of covariance of ut comma covariance of ut minus 1 is is equal to 0. There is no time lag between the the covariance between the type, between the two different times. So one simple way of detecting that stationary is that you plot in a just plot the data in any graphical mode, and you can see whether it's a line bar or a histograph or what do you call it, 3D figure, whatever. Nowadays there are a lot of techniques there through which you can actually visualize the data movement. From there you can understand. But if you want to correctly actually understand how the data is moving, you need to do some mathematical test. So that mathematical test is known as unit root test. That mathematical test is known as unit root test. So unit root test is otherwise known as non-stationary. So this unit root non-stationary, in this analysis I'll use what is a synonymous term. So with all the stationary test, I'll use that it as a unit root test. And the null hypothesis is that data, there is a unit root exists. That means data are not stationary. So if you talk about again that stationary data divide, for tackling the stationary data, you have two types of data. Like when you have distributions, like a parametric distribution and non-parametric distribution. When you have parametric distribution, so your distribution is known, whether it's a normal distribution or whether it's a binomial distribution, or whether it's a Poisson's distribution, or whether it is a probabilistic distributions. So there you can use the parametric techniques. But when your distribution is not known, then you use actually non-parametric test. So for parametric test, in case of unit root test, you use two types of test, that is decupllar test and augmented decupllar test. For non-parametric test, you use one type of test here, which is known as like Phillips parent test. So let me discuss decupllar and augmented decupllar. Then I'll go for parametric test. So this is decupllar test. This is random walk with drift and random walk without drift. So delta yt equal to beta 3 yt minus 1 plus ut. That means any figure actually depend upon his lag figure. So this is known as auto-regressives. Okay. And when you take intercept like delta yt, beta 1 plus beta t, and your time period is involved there, and that is with drift. Okay. When you like sometime we call, then there is a correlation between error terms and the change of your dependent variable. So in order to eradicate that correlation between the error term and the difference between the dependent variable, here in augmented decupllar test, we actually add the lag of the dependent variables. So that is summation I goes from 1 to m delta yt minus 1. So augmented decupllar actually corrected that correlation between the dependent variable, the difference of dependent variable and independent and error terms. So, and other tests are, as I told, for non-parametric test, that is a Phillips parent test, KPSS test, NG parent test. So what I mean to say that all these tests are actually all these tests have the simple objectives to test whether the data is stationary or not. So for testing the stationary, we use actually unit root test. So that under unit root test, let's do one test, understand what is the hypothesis of decupllar test, decupllar test, or the advanced test we can take augmented decupllar test. In an augmented decupllar test, you have a null hypothesis which is telling there is a unit root test. That means data is non-stationary. As you told as you know that in a empirical analysis, in a hypothesis testing, what you try to actually prove, you take opposite of that in actually null hypothesis. So that's why null hypothesis is known as false hypothesis. And alternate, yes. Yes, somebody. Yes, some sound is coming. Can you mute it? Just a minute. Why is this slide?
Sir, kindly continue, sir.
Okay. Yeah, I understand. No problem. I thought somebody is asking some questions. Okay, no problem. So in a unit root test, that null hypothesis that data is non-stationary, or there is a unit root test, there is a unit root. Okay, so that is a unit root test means data is not stationary. So if I reject the null hypothesis, because my null hypothesis is that if I'll take one, I'm giving a simple example. If I'm taking inflation like 125 week inflation data, and I want to test whether this data is stationary or not. Without doing stationary, I cannot do any empirical analysis of this time series and time series data. So what I'm doing, so in empirical analysis, whatever you do through the hypothesis testing, because whatever you tell in verbal, that doesn't have meaning. You have to prove through the hypothesis testings. It's like with empirical supports. So your null hypothesis that inflation data are not stationary, or inflation data does not follow stationary. So the alternative hypothesis that inflation data follow actually stationary, or inflation data are not stationary. Or you can take the null hypothesis that there is a unit root in inflations, or alternative hypothesis that there is no unit root in the inflations. So if your data is, then if your result is significant, if your either decoupled test or augmented decoupled test, if the result is significant, then we can reject null hypothesis. If reject null hypothesis means we can reject null hypothesis that there is a unit root to exist. That unit root exist means that inflations follow non-stationary. If you reject that inflation follow non-stationary, your alternative hypothesis is that inflation follows stationary. Then inflation follows stationary will be significant. If the opposite happens,
sir, please repeat once again, sir.
Yes. Like in a hypothesis testings, you have a critical figures and you have a tabulated figures. So your data becomes significant when your critical value is greater than tabulated value. When your critical value is greater than tabulated value, then we'll tell that your test is significant. And why are test significant required? Because knowingly we have kept alternative hypothesis what we wanted to prove, and we wanted to reject what we have kept in null hypothesis, and we want to reject that in null hypothesis because we want to make the test significant. And if we reject null hypothesis, then our alternative hypothesis will be expected. And in a null hypothesis, we have kept that inflation follows unit root test, or data of inflation is non-stationary, and we have taken in alternative hypothesis that inflation unit root test does not exist, or data of inflation is stationary. So if you can reject null hypothesis, then my alternative hypothesis will be true. So by rejecting null hypothesis and expecting alternate hypothesis, the process of significant telling a test is significant. Like simply what we are doing the hypothesis testing. Here in case of decoupled test and augmented decoupled test, the same test same logic you are following. If the null hypothesis and like that, in case of decoupled test and augmented decoupled test, we have a null hypothesis and alternative hypothesis. That is B3. Okay, which is the coefficient of ut minus 1. Okay. So if you reject that one, that will be, because alternative hypothesis you already tell that is a stationary test is there, and that is non-stationary. If you tell that is wrong, then our alternative hypothesis will be correct. Okay, or we will expect our alternative hypothesis. So you test any decoupled augmented decoupled test, then what will happen? Your test will be significant. And the opposite will happen if your calculated value is less than tabulated value. If the calculated value is less than tabulated value, that is the process of non-significant. That means we are expecting the null hypothesis. What you have kept in null hypothesis, unit root process or non-stationary. So if you are expecting the null hypothesis that is not stationary, that means that is a non-stationary.
Can you explain?
Yes, what I need to explain?
Can you, sir, explain tau statistics in augmented decupolar test?
That is only tau statistic. I'm not telling you some people. So in decupolar test or augmented decupolar test, that is like in normal hypothesis we take t-test, and decupolar and augmented, that we get that actually tau statistic. This tau statistic, the procedure is same. If the tau statistic, that calculated value is less than tabulated, if the calculated value is greater than tabulated value, then that test will be significant. Okay. If the calculated value, like any statistic books, you have, with your degree of freedom, you have a tabulated figure in your books. In a table, if you see like your T statistic, also in a, like if you see that famous book, SP Gupta books, also you have a tau statistic figure is there with different degree of freedom, and with different degree of freedom, with the like 5%, 2.5%, 5%, 10%, you have different degree of freedom, and from there you can find out actually your tabulated value. And your calculated value is from your, like when I'll do hands-on experience for time series, you can understand, you will get one figure for decupolar or augmented decupolar. Then you have to compare. If your calculated value from that value from which you are getting from software is greater than your tabulated value, then your test is significant. That means you are rejecting null hypothesis and your process is stationary. That means your process follows what? A definite pattern. Stationarity means your process data follows a definite pattern. That means whenever Chinmay will see me, he will give regard to me. He will not give a slap to me. If he is giving a slap to me, that means there is a abnormal behavior is there. Data is actually in a certain period of time it will fluctuate. Getting my point? Chinmay, don't take it like in a bad manner, bad way. Just I'm explaining this example to my student to understand that. Chinmay, are you there, Dr. Chinmay?
Yes, sir. Yes, sir.
Yeah. Just I'm explaining that they should understand what is that. Okay. What is the normal behavior?
Yes.
So this is only the actually one part of the story. So after doing that, if I realize the data is not stationary, so what I should do? So if the data is not stationary, anyhow I have to do the data stationary. So the next step is that process of integrations. Okay, the process of integrated time series. So in case of integrated time series, what happens when your data is not stationary? So what you have to do? You have to do the fast difference. Like you can do n number of difference. So when you the data is not stationary, you can do the first difference. They can go for second difference. You can go for third difference, and you can go for n number of, that is called ID. That integrated of time series. And another demerit of integrating time series, that so it is expected that you should not go for more than 2 difference, because once you do the difference, you actually lose the 1 degree of freedom. So the time that if you do more degree of like difference, you keep on losing the 1 degree of freedom. What is the different process of differentiations? Like when you have time, like time series data from 1950 to 51 to 2023, when you do like I1, so what do you get? In case of 1950, that will be a blank. In 1951, what will you get? 1951 minus 1950. That will be your time series 1. And for time series 2, what will be there? 1952 minus 1951. Third one, 1953 minus 1952. 1954 minus 1953. So you will get that first item that 1950 will be blank. Getting my point? And if you do two difference, 1951, 52 will be blank.
Yes, sir. You may lose one set of data,
Yeah,
one
yeah,
point of data.
one
If
second.
you
So in
depreciate one time.
yeah, in the time series data, it consider if your degree of freedom is more then your that result is very robust. So
Yeah.
at any time,
If you are having, but if you are having more number of data points, then that does not affect your results. Means
yeah,
if you have 100 points
yeah.
and you are losing 1 point, means there is no effect.
Yeah, so if you have a huge data point, then doing that it doesn't affect. But there are some analysis, like if you talk about that, you do one analysis like what is the impact of globalization on Indian economy. Globalization happened in 1991. Okay, so I can take only data after 91. So from 1991 to 2023, it is only 34 years data. So if I do 3-4 years, 3-4 times differentiation, so I lose my 3-4 valuable data points. And then if I do the 3-4 data point, then it will be my degree of freedom will be 29. And in 29 time series data, if I do analysis, that is questionable in a time series literature. So time series literature, if you do like with 29 data points, the people will ask question that is a question mark on the credibility of the time series analysis. I'm telling you.
There is no sufficient data.
Yeah, because some analysis you need to do on the basis of time. Like you will see that after some time, like post demonetization, post COVID analysis will be more significant, and that time your time series data will be. Now people are doing with taking monthly or daily, like COVID data, daily data is available, or if yearly or monthly. So that monthly it will take or yearly take, it will be very small like data. So that time, but if you have a huge data, like if you are doing a financial analysis and you have a stock market data, so you don't face any problem. What you exactly said. Okay. So this is what actually like you do actually in time series. That means once you do actually stationarity test. Okay, so stationarity test, you do the different stationarity. Then by doing, then when your data will be stationary, then you can go for any type of test, either any simple, even if you are doing a two variable regressions by simple bivariate analysis regressions, that is also you need to do the stationarity. Is it clear? What is stationarity? Or any doubt?
Sir, can you explain how to convert a non-stationary data into a stationary data again?
For that, I need to do that hands-on experience. So, okay, that I'll do.
Sir, sorry to interrupt in between. Sir, I have a question.
Yeah. Yes, please.
Sir, this time series analysis, what you are studying, this has to be adopted when you are doing secondary data analysis.
Yeah, second data means, yeah, second data.
Not on primary.
The primary data, it is a cross-sectional data. Like your data for a particular period of time, but a cross-sectional data for like if for like 20 periods, if you have like if you have go again and again like do that cross-sectional data will be a time series data. Okay. Only that when you have a fair number of frequency, your cross-sectional data also become time series data.
Okay, sir.
So that means stationary is required only in time series. Also, I am not talking about panel data. In panel data also stationary is required.
Okay.
So that is another set of lectures, and there the test of panel data is also different.
So in case of finance, so how will apply to this time series analysis?
The same in finance, people also using this test.
Okay, sir. Thank you.
Okay. Let's now give me like some 40-45 minutes. Let's to complete some of the things. Then we'll have some times 30 minutes. We can have discussions. I'll tell 2-3 theories. then I'll do hands-on, then we'll have some satisfaction, then we can have debate. Is it right?
Sure,
Yes,
sir.
sir.
Okay. Okay, actually somebody asked me, sir, to tell us how to do that stationarity. That I'll do, but before that, little bit like since some of my advanced student is there, for them I should do some justice. 2-3 techniques I should teach that I should tell them. So then also they will get some satisfaction also. So in a time series analysis, simply that researcher, when they do analysis, they at first they do multiple regressions. So the multiple regression you have that you have already know that. I don't need to explain that. You have a dependent variable, you have more than one independent variable like 5, 10. You can take and you can check the multiplicating, then you can fix your model, then a lot of interpretation will come. That we'll talk about that maximum. So in the first step of their analysis, that they do actually regression analysis. Some sort of people who actually, after doing regression analysis, even if in a PPG dissertation, after doing, they do some kind of, like, we cannot call it advanced. People do causality and VAR, and there are a lot of techniques that coming. So let's discuss what is causality. So if you have two variables, X and Y, so anybody can tell how many possibilities there, the relations between an X and Y. How many possibilities there if I have two variables, X and Y, from the cause and effect relationship? What are the possibility? Anyone can tell? Yes, that if you have X and Y, there is a 4 possibilities there. What are the 4 possibilities there?
X can cause Y, Y can cause X, and
Yes, I've written, just you read. So there are 4 possibilities. X can cause Y, Y can cause X, X and Y both cause each other, X and Y does not cause each other. So the first two are known as like unidirectional causality. Whether X cause Y or Y cause X is known as what? Unidirectional causality. Only cause and effect happens from one direction to other direction. Like if I give you FDI and GDP, or if I'll give the growth figure and investment figure, so nobody can tell whether growth is causing investment or investment is causing growth, or FDI is causing growth or growth is causing FDI. Is a chicken and egg question, whether chicken is fast or egg is fast.
Yeah, there is a simultaneity.
Okay. So this is a model which is known as Ganjar causality model, which has Ganjar was introduced in 1969, and also he got the Nobel Prize subsequently. But Ganjar has actually explained in a different way. But when X and Y they cause each other, it is not an instantaneous or what we call a simultaneous process. There is a lag effect actually involved for a cause and effect relationship. That this year growth you are realizing, it is not only the cause of that previous year investment. This year growth is also influenced by the previous year growth as well as previous year investment. Getting my point? So that's why Ganjar in 1939 has specified this Ganjar causality. What is that? He has taken growth rate, so GR GDP is equal to growth rate of GDP, and FDI equal to foreign direct investment. Basically, I was for a decades I was doing research on FDI and growth, so that's why I have this simple class for I have taken that. So growth. So that means growth of GDP depend upon that growth, the previous year growth, as well as previous year foreign direct investment. And again, if I'll take again FDI into the dependent variable, FDI also depend upon the previous year FDI and previous year GDP. So they're telling FDI can only affect GDP that if that previous year FDI actually affect the growth, because it's a dynamic relationship. Today, this year growth depend upon the last year investment. Here, the investment have taken in form of FDI. It's not like this year you do there are some investment is there. So within 1 year it shows, but that is a very low. But maximum project is that you need a time lag. So that's why here H0 equal to that summation J runs from 1 to Q, delta J equal to 0. And that alternative hypothesis that H1 equal to summation J run from 1 to Q, delta J is not equal to 0. So when if your delta J is not equal to 0, that means that lag of FDI, previous year FDI, has impact on growth of GDP. And growth of GDP of the lag of the already that it has a relationship. But FDI, only this delta, what you call only this delta, if it will be like it will be a positive number, if it will not be 0, then only it has impact on this. So then only you can tell that FDI is causing growth. Like that, you see the second equation. What I have to tell you? Sorry, the first one is rho, summation rho, second one is delta. Sorry, first one is rho and second one is delta. So in case of H summation J equal to N, delta is equal to 0. And H1 equal to summation J equal to N, delta J is not equal to 0. That means if is not equal to 0, then this growth will impact in FDI. So when you do like this type of specification, you do analysis in the simple, like any software, you get this Ganja causality result. So this is null hypothesis and alternative hypothesis. In the first hypothesis that FDI does not cause Ganja causality. So here your F statistic is the probability value is 0.90. So this test is not significant. Only the second one is significant where this p value is less than 0.10. Then we can reject it. FDI, like GR GDP does not cause. So that means FDI is causing growth rate. So what is the result? That FDI is causing the growth rate. Is it clear? What is Ganja causality? That will do. When I'll do hands-on from there, you can understand. Okay. Let's go to the another like techniques, which is known as vector auto regressions or VAR. VAR is very useful when you do like your like relationship as well as in arithmetical model. So that's why in VAR that is assured there is no dependent and independent variables are there. There is a simultaneous relationship which is there. So if you talk about macroeconomic modeling, like if I give the 10 variables, different variable, GDP, investment, repo rate, money supply, foreign exchange reserve, interest rate, foreign direct investment, foreign institutional investment, these are the figure. All these variables, they actually affect each other. That means there is a interrelationship actually is there between all these figures. Only difference is there in which lag they are actually impacting each other. If I take GDP equal to dependent variable, FDI, investment, inflation, foreign direct, like foreign exchange reserve as an independent variable. So the current year GDP, when you do that VAR analysis, that from the process of VAR, you try to understand which lag period actually has significant impact. Whether previous 3 years or 4 years has more like significant relations or not, or just last year. So in the lag theory, it was a different, like you have a decay relationship that when your lag is more, the impact keep on decreasing. And some other set of authors they are telling no, it is fluctuate. In it may be occurs that your immediate lag doesn't have relations. After 2-3 lag, you have a significant relationship is there. So for that doing in the VAR analysis, we do actually for doing the lag length selection, we take help of some criteria. There are different type of criteria. Is that the famous criteria of like lag length selection is known as archaic information criteria, which is known as AIC. Apart from archaic information criteria, you have a Swatch criteria, you have a Hanan criteria, you have a small that forecast error criteria, something like 4-5 criteria is there. But any criteria you can take, and if I would like, you can take archaic information criteria and different lags you run it, and you see in which lag that archaic information criteria value is minimum, that model is considered as the best model. Okay. So in the VAR model, the lag length selection is very important. For that, we take the help of archaic information criteria or Swatch criteria. So in advanced like techniques, what they are doing, they're taking the family of criteria and they're telling, like if you're taking the 5 lag length criteria and we want to know what is the best model. So out of the 5 criteria, if in a lag, like 3 lag, if your three test is telling out of 4 tests, the 2 lag or 3 lag is the best lag. So you take 3 lag, 2 lag is the best lag. Getting my point? Either one individual test criteria, lag length criteria you take and compare across the model, or you take family of criteria and you take in which lag the maximum criteria is giving the minimum value. Am I making any sense? Are you getting me? How to?
Yes, sir. Yes, sir.
Are you getting? Am I audible?
Yes, sir.
Okay. So from that you understand what is the. So from the lag length criteria you define what is the best model selections. Okay. So as I told that what are the problems of the criteria is that VAR is a theoretical model. Like theoretical model means behind VAR there is no theories there. You get different variables and you try to use your lag length selection criteria and try to define your model. Okay. So it emphasizes on forecasting, less suitable for policy analysis, and there is also degree of freedom. So when you take actually more lags. Okay. This was the theory I wanted to like cover today, and I now will do some hands-on experience. So in hands-on experience, like you can do there are different softwares is there. Either you can do with eViews, or you can do with like if you have license version software is there, you can do with eViews, and if you don't have, there is open source software is the R software is there. So if you want to do R software, a little bit coding you need to understand, you need to devote some time, and you can like in R software you can download R as well as R Studio software. From there you can actually write that coding. It will take some time, but you'll able to do that. So for that reason, you don't need to like take any license software. But if you are doing, you want to do in very less time and you don't want to know how the process, how your things are happening, so you can use either like a time series, you can use either Stata or eViews or Great Trail or mini tabs. So basically our economy student, they use actually eViews or Stata. So for stationary and all this test, eViews is more like helpful. So what we'll do today, I'll do with all like what theory I have taught you, that I'll do with the eViews. So then it will be easy for you to understand. So before starting the eViews hands-on experience, I also again would like to know how many students they have exposure on eViews. Can you raise your hand? Only 15 students. 14. Okay. So near about 20-25 students or they know the reviews. So I should see that primary or cross-section data. If you want to do data analysis, you can use SPSS. Okay. But for this secondary data, you need like eViews. So primary data, like if some students are interested, we can in a different day we can do one hands-on with the SPSS. And but today, since I've talked about that stationary, we'll do in the eViews. Okay. So I think very less students they have actually eViews. So, but I'll speak slowly. You can understand and try to do with the help of eViews. Okay. So those students who are doing research on finance and economics, basically in macroeconomic modeling, so this eViews will be helpful for them. Okay. So those who have eViews, they can do with me. Okay. So this is like eViews package, which is the full form of eViews is the electronic view. So here, somebody was asking me when I was teaching the theory, sir, how can we do that stationary from, how can we convert, how can we do that stationary from a non-stationary data? That I'll show you. Okay. So here, when you go in eViews, so there is a like menu is there, file. So in menu file, you can new file. It takes all the extension file like Excel, your Word file, CBS bill delimited file. Also, the Stata has his own extension file. But if you had say after saving, so generally it is from a user friendly point of view. From you can import data from Excel. So what I have done before doing that, I'll show my data series what I've kept and how I'll import in eViews, and then how after that how I process it. So on 9/7/2023, I have kept the data. Okay. Okay. So this is the different macroeconomic data I have kept. That is FDI, gross domestic product and factor cost, growth rate of GDP, gross domestic capital formation, that is investment, foreign institutional investment, that is FII, export, that is XEX, that is IMEK import, then foreign exchange reserve, that is FER, then openness, that is openness of Indian economy, that is export plus import by GDP. Like that we determine. Okay. So these are the figures we can do. Please try to understand when. Is it visible to everybody, my data?
Yes, sir.
Yes, sir.
Yes. So
Yes,
what
sir.
I'll do, what I'll do when I'll do my, so the simple understanding is that when I'll do my data analysis, when I have this type of time series data, I should check the stationary of each and every variables. If they're stationary, it is okay, but if it's not stationary, then I have to convert into the stationary, then I'll use these variables. Okay. So I'm just telling by in the Word file, I'm just doing that. Okay. If I'll take this, just I'm creating. Okay. For example, I'm just doing that. When I'll do the stationary analysis and I will see something is not stationary, I'm just explaining what is the process of differentiation. What is the process of differentiations? That you only subtract this to this, current to previous. Okay. So this is equal to this C3 minus C2 minus C2. Then you get this figure. Then after that, what you do? You drag this. Then you get the entire series.
So these are the first differences which we are calculating.
Yeah. And what I told, your first figure will be nothing. So it will be blank.
Okay.
Okay. So I'm just closing this one. And please try to understand when the issues when you're working, your Excel sheet should be closed. So now you can go to File, open the data. In Open, you can click. So in my desktop, I have kept in like 9/7. Click there. And when you just right click on Excel file, you can get one data. Click it. Okay. So what data I was just reading that, all the data are available here. Okay. Okay. So you can, again, you can do next. Then you can do next, keep on doing the next, and you do finish it. Then yes, you want to import, yes. So now you will get one work file in a image. Okay. You'll get one work file in the image where all this data I have kept in Excel's growth. So this is the GDP data, what it was there in Excel file from 1991 to 2015. So this has actually imported what? To Excel sheet. Okay. Like that, you close it. Then, for example, this is FDI figures. So this is the FDI figure. In 1991, you had 360. 1992, you have 965. If you want to check it, whether in 1991 316 was there or not, you can close. Again, you can open your Excel file. See, in the FDI, it was 1991 equal 360, 1992 equal 965. Is it right now? Is it clear to now?
Yes, sir.
So this is there. So what I told, then one by one you check your data. Then what is the next step is that you need to do. Then you go to the file. Okay. Under file you have a view is there. Okay. Under view you have a different option is also there. I told there is one graphical method to understand whether your data is stationary or not. That graphical method is known as correlogram. Correlogram, correlogram. So in the correlogram, when you click on correlogram, you have a different, both the side you have a band is there. If your data exists within that band, so it is stationary. If it's going beyond that band, it is not stationary. So I'm just doing the correlogram of that. Okay. See, this is the figure, which is the actual figure of a correlogram. Now you see, we have actually band in two sides. In some of the lag, your data is outside that band. So So if your data is not within the band, so what I told that your data is not stationary. Is it clear? So what we'll do? Now we'll do fast difference through which in the fast difference we'll see whether a data will stationary or not. So you can go to view, again corollagram, instead of label. Label means without doing any difference. Which that means with the raw data we're trying to understand if from a graphical point of view whether you are stationary or not. So again, when it is not stationary in the label, what we are doing the fast difference. So we click on fast difference, just click on fast difference. Now, can you see in the fast difference? Everybody, can you see in the fast difference?
Yes, sir.
So in the fast difference, what is the case? In the both the like autocorrelation and partial correlation, your data is within that band. Band means in the both side you have a dotted line. Na? When in the corollagram, when you are in the level, what was the case? Some of your like band was outside that dotted line. Okay. Here 2, 3, here also one word dotted line. But when you go and do that corollagram and do the fast difference, what happens? It is within that dotted line. Is it clear?
Yes, sir.
So this is the corollagram is a graphical method of understanding the data is whether the data is not stationary or not. So from the corollagram, we understand data is not stationary, and with the fast difference, we have made data stationary by clicking the fast difference. Let's try to understand the same story with the help of mathematical techniques, that is decupular test and augmented decupular test. Clear? In the graphical method, that is corollagram, we have understood that,
Yes,
that FDI figure is not stationary, and after doing fast difference, that FDI figure is becoming stationary. That means we are making normality by doing the fast difference. In a very layman point of view, who is not from economics background, they should understand. So please, those who are not from economics background, don't think that I cannot understand. Some little bit of more mathematics involved. Don't think like that. Half an hour is there. After 1 o'clock, I'll stop my lecture. There you have to ask the questions. Very simple way, and I'll explain in a very simple way why it is like that. Don't be disheartened and some mathematics, some figures. You don't think that I am not from economics background. I cannot understand. I'll try my best to make you convince how it is happening. So please reserve your question, and that half an hour you can ask. So once that graphical part is finished, you can go for mathematical test. So this mathematical test, what I told, that is actually unit 2 test. So then unit 2 test is divided into 3 types. So on a standard unit 2 test, that is back breakpoint unit test and sizzle unit test. So what we'll do standard unit 2 test, because in breakpoint unit test, what happens when you break, that your data across the sample does not behave same way. So that is a breakpoint is there. But for time being, we'll do the standard unit 2 test. So under standard unit 2 test, these are the techniques are available, which I told: decupular test, augmented decupular test, Phillips parent test, QRTC Phillips Simpsons, that is KPSS. It's some Chinese names, 4 or 5 Chinese professor they have has done it. So it is KPSS. Then NG parent test, ERSP test. But generally we use decupular, augmented decupular for parametric, and Phillips parent test for non-parametric test. Let's understand with the data from decupular test whether it is a stationary or not. Okay, click.
How to identify that it's parametric or non-parametric?
Because it's a very simple. You have to see your if you want to do that, if you want to use augmented decupular test, that is a parametric test. In case of parametric test, you have to do the distribution test. If your distribution is normal distribution, then only you can do what? This parametric test. But if you are not doing any distribution test, that means your distribution is not known to you. So instead of decupolar augmented specular, you should do in Phillips parent test, which is a non-parametric test. That is that means if you are not testing any distributions, that your distribution is not normal, because one of the assumption of that classical linear regression model is that your variable should be a normal. That means it follows the normal distributions. IID, that is independent identical distributed. If is that is then if it has normal distribution or bell-shaped curve, only you can use this augmented decupolar or decupolar. So if it is not normal distributed, you have not checked distribution, you directly, instead of doing that, you do the Phillips parent test. Getting my point? What is
Yes, sir. Thank you, sir.
parametric and non-parametric test?
Yes,
Okay.
sir.
So what we'll do in this decupolar test, we'll do with the label. Okay. Just 1 minute. That is label. So see. So this is the result of decupolar test in case of in case of decupolar test. So in case of decupolar test, what is null hypothesis? The null hypothesis that FDI has a unit root test. The FDI has a unit root test means the null hypothesis telling FDI follows non-stationary. Am I right? What I told according to the theory? What is the null hypothesis? FDI follows non-stationary. Or data of FDI is non-stationary. Unit root means non-stationary. I told you unit root, the synonymous word of unit root test is non-stationary. So that means FDI is non-stationary. If I can reject my null hypothesis, then only my data will be stationary. Here I cannot reject my null hypothesis because please see the test. It is the tau stat is equal to 0.07. But what is the this is the calculated value. This is the tabulated value. Tabulated value is -2, 1. Please, so here please ignore the minus. Okay. In case of because it is a two-tail test, left-hander, so you have to take the absolute value of this. So here your tabulated value is greater than calculated value. Your calculated value equal 0.07, your tabulated value equal 2.6. In 1%, in 5%, 1.9, in 10%, 1.6. So minimum is 1.6, which is greater than your calculated value equal to 0.07. So when your calculated value is, so here your calculated value equal 0.07. So when your calculated value is greater than tabulated value, so that means that process is non-significant. So the process is non-significant means we expect null hypothesis. We accept null hypothesis means FDI has a unit root test. That means FDI is non-stationary, which we got through the parallelogram. Please mute. Okay. Is it clear? When
Yes,
your
sir.
calculated value is less than tabulated value means you expect null hypothesis. Here null hypothesis that FDI has unit root test, that means FDI is non-stationary. So when you expect FDI is non-stationary means so FDI is not following non-stationary. So what is our next step? So I have to do I have to do the first difference. Like in parallelogram, we have already saw in the parallelogram is that this is not stationary. So what you have to do, again you go to the view, then unit root test, then standard unit test. Instead of label, what we will do now? I'll do first difference. Okay. Now you see in the first difference what you are getting. Now your first difference, the unit root test is same. The difference of FDI has a unit root test. That means difference of FDI is a non-stationary. Now you see your calculated value equal to 3.48. The tabulated value equal to 2.66, 1.95, 1.66. Here your result is different. Your calculated value is greater than tabulated value. Your calculated value is greater than tabulated value. This means the process is significant. So if the process is significant means we will reject null hypothesis. We'll reject null hypothesis means we'll reject that FDI has a unit to test. FDI has a unit to test means FDI follows non-stationary. So FDI follows non-stationary. If we'll reject that, what is the alternative hypothesis? FDI follows stationary. So we expect FDI follows stationary. So when the calculated tau t statistic or tau statistic is equal to greater than tabulated value, that proceeds stationary. So here in first difference, it is stationary. Is it clear?
Yes, sir.
Is it clear to everybody? So then next go for unit to test standalone, that is augmented decupula test, which actually try to actually remove the correlation, that co-collinearity between error term and the dependent variables. So in the label again you do that. In the label again the same stories, that your calculated value is less than the tabulated value, so it is not stationary. See, 1.17 is less than 2.63. So what I have again to do in case of augmented decupula test? I have to do the first difference. When I am doing the first difference, what is happening? So it is greater than, only for 1% it is small, but in 5% and 10% is greater than 3.47, is greater than 2.99, 2.63. This is only like parametric. But if you are doing the non-parametric test, so you should do for Phillips-Perron test. You should do for Phillips-Perron test. So let's do the Phillips-Perron test. That means your distribution is not known, or by mistake you have not done the distribution test. Okay. So it is Phillips-Perron's label. We do that. What the result you are getting in Phillips-Perron? 1.37 is less than 2.63, is less than 2.2, 2.99 is less than 3.73. Okay. So this Phillips-Perron test, which is a non-parametric test, is telling the data is non-stationary. So what we have to do? Go to the unit to test standard, then you do the first difference, Phillips-Perron test. So in the Phillips-Perron test, you can find out is stationary in 5% as well as 10%. Sometimes what happen in 1%, it does not significant, but if you only probability level 0.0, then otherwise in 5% and 10% is significant. So it is.
So sir, in this case, what we'll consider the 5% level.
You can see in the literature, the thumb rule is that we consider in the 5%. Sometimes also people consider in 10% also. Okay.
Okay, sir. Okay.
So
Thank you, sir.
So that is the difference. Okay.
Okay, sir.
So this is how actually we do like stationary test in case of graphical test as well as mathematical test. Another things I actually told is like I have taught you, that is Ganser causality. Okay. So let's do the Ganser causality. This is so in E-views under quick, you can write down under quick you have a group statistics. Under group statistic you have a Ganser causality test is there. So you can go and click the Ganser causality. Then you can write FDI or growth rate of GDP. Okay. Then you click it. The same example what I have told you in my PPT, this is the result 0.06, 0.95. You can, if that is there, you can understand 0.9578, 0.0631. So this is the result we are getting 0.0361, 0.95 Ganser causality test. Okay. So if you want to take more variables, your Ganser causality test, you want to do the multivariate, so you can take GDP, growth rate of GDP, you can take import, you can take export, you can take FDI, FDI also you have taken, you can take openness. Okay, that means this is a multivariate Ganser causality test. Okay, you click. See, one thing I'm not changing, that is a lag. That is I'm taking default lag. You can change your lag 1, 2, 3, 4, and you can get the different days. So when you have a more variables, so you get the different result. So here this is significant, this is not significant, this is not significant, this is significant, this is significant. Here export and import both are causing each other because both the calculated value is greater than the, so when you become expert from probability value, you can understand actually which value is actually causing each other. So if you have more, like you are working in a thesis, you have 8-10 variables, so you can take all the 8-10 variables like this Ganser causality result, you can find out, you can keep on interpretation, you can write down the interpretations. Is it clear? So the last item what I have taught you, that is var. I'll show you, then I'll take question from you. So you can go to quick. So you have okay, quick, you have a group statistic. And then var is estimate var. Okay. So you can take endogenous and exogenous variable like FDI, growth rate of GDP, openness, import. In var you need fairly more variables, then will it make any sense. See, this is a var model, okay, that is called vector autoregressions. Why it is a vector autoregression? Autoregression means when you take the lag of your own variables. Why is a vector? Because you are taking more than one variables. So if you literally try to understand, here FDI is the function of, FDI is affected by his two, because you have taken two lag. FDI is a function of FDI lag 1. So here FDI is dependent variable and all these are independent variable. FDI lag 1, lag 2, growth of lag 1, growth of lag 2, openness of lag 1, openness of lag 2, import of lag 1, import of lag 2. So here one dependent variable, 1, 2, 3, 4, 5, 6, 7, 8 independent variable. Like that, again you take growth rate as a dependent variable, then your independent variable will be FDI 2 lag, growth of 2 lag, openness 2 lag, import 2 lags. Then you take openness as a dependent variable, then all these variables are independent variable. Then you take import as dependent variable, all are independent variables. So in this process, what is happening? All variables are getting a chance to become independent as well dependent variable. So there is a interrelationship are available. Okay, so it is not like you are not fixing one variable is the dependent. Like in a regression, we only fixing what is dependent variable, what are independent variable. But in var, we are giving opportunity to each and every variable to become independent as well as dependent variable. So we can understand what is the interrelationship and that to which lag is significant. Okay, so I also told in case of var, you need to do the lag length selection criteria. So go to var. So here is one stock like option within that. After when you get the var result, you go to view and you click on the lag structure. In the lag structure, you have a lag length criteria. In lag structure, in the fifth menu, we have a lag length criteria. So click that on the lag length criteria. So then if you want to take more lag length selections criteria, lag include, for example, 3. Okay, so see, you have a 1, 2, 3, 4, 5, 6. or you can go for view. Take like more lag instead of 5 is 5 is get some data is very small. So this see, I am not told one things. So this is the estimations of your model. So this is your FDI model, first model when your FDI is dependent variable. This is your second model when the growth rate is your dependent variable. This is your third model when openness equal dependent variable. This is your fourth model when import is variable. So it will give your model specification also var. Also in second also it will give the coefficient of your model specification also. Actually dependent variable and which is actually independent variables. Okay. So and then you go to laglet selections. Okay. Go to 4 lag. Okay. So in the 4 lag, you please try to understand what I told. You have 1, 2, 3, 4, 5, 6. This is archaic information and this is Schwartz criteria. It is written what are the criteria. The first one is LR, that is LR statistics, likelihood ratio statistic. The set this was FP equal to final prediction error, that is also lag length criteria. That AIC equal to archaic information criteria, SC equal to Schwartz information criteria, HQ equal to Hannon Quinn information criteria. So these are 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. So you see in the fourth lag, maximum value is like is telling the minimum maximum value. What happens is giving the minimum values. So if you see the archaic information criteria, in case of 4 lag, it is giving minimum value, that is 42.22. In case of like all other lag, what is the value of archaic information criteria? It is 54, 46, 45, 45. Then last one is 4 lag, it is 42. What I told, the model will be best model when it will give the minimum value. So in archaic information criteria, this lag is giving minimum value. The same story in case of Schwartz criteria. You see lag 1 giving 54, lag 2 47, 44, lag 3 47, 67, lag 3 47, 69, lag 4 45, 60. So that means 4 is also giving minimum value. In case of Hannon criteria, also Hannon Quinn criteria, also lag 4 is lag 1 is giving 54, lag 2 46, and lag 4 is giving minimum value. So that means what is happening? And also in your FP also it is giving minimum value. So that means 4 out of 5, 4 is giving the minimum value in the lag 4. So 4 lag is the best lag in case of VAR model. Understood? So now I am out of time, that to 1 o'clock. So now it's your time. You can ask questions. Those who are not from economics or finance background, what I taught you, that you can ask question and I'll be happy to answer your question.
Sir, as you have
Just let me
sir, as you have explained the time series analysis. So basically, if we have a time series data and we need to analyze the data, so we need to perform these 3 tests. Like we have to check the stationary, then causality, and then war.
No, these are different types of tests. I don't told that you do all these things. There are so many tests also. Today also I was thinking Arima also I'll teach. See, I don't have time, that's I'm not teaching. So I'm telling these are one tests. Since some of my advanced students, they called me, they told, sir, you should test Ruti Bansal. Can you mute? There is some sound is coming. Okay. So Rupansi, you asked
Yes,
this
sir.
question. So Rupansi, actually what techniques you will use, it depend upon your requirement. That stationary test is compulsory. I told stationary test is compulsory. For stationary, you can use any test. Correlogram you can test. You can
Yes, sir.
you can do correlogram or decupolar or augmented decupolar,
Parallel.
or you can do everything and you try to report. But I told that you need to test is compulsory for time series. But causality, VAR, ARIMA, ARDL, NRDL, so many tests are coming that what you want to do, that stepwise regression, whatever, multiple regression, whatever, that according to your research problem or according to your requirement, you will do it.
Okay, okay, sir. So that I would be applying depending on my research problem, that what I want to find.
Yes,
Yeah.
yes.
Got it.
Excuse me, sir.
Yes, I'll share your PPT. That
Excuse me.
PPT to Chitra sir. Chitra sir can share with you.
Excuse me, sir. Am I audible?
Yes, you are audible.
Sir, I want to know if is it possible to run the control variables into the model, because I don't know how to include the control variables.
Yeah. Control variable. Yes, you have asked actually very good questions. Like, you know what is multipolarity problem? Do you know what is multipolarity problem?
Yes, sir. I do know.
Yeah. See, Jagdish, I told I'll share my PPT with Chitra sir or Professor Meenaketan, so you can take all the PPT. Absolutely no problem. Okay, you can take and you can read. And in fact, a lot of PPT are available. The only problem is that you need to understand the concept. Okay, that Shruti, you asked the question now.
Yes,
How to
sir.
control variable. So the control variable is when you are doing multiple regressions analysis, so you should do stationary test. Okay. So what first is stationary test. The second one you to do the specification test. Those variable you should include in the control variable. Already, for example, in a variable you have taken one dependent variable, 3-4 independent variable you have taken. You should not take another variable which has a high multiplicative with your existing variables. You take another variable which does not have any correlation with your existing 3 variables. Then only that will act as a control variable. Okay. If you have taken investment, again you are taking FDI, and FDI investment has a high correlation, that is multipolarity is coming 0.6 or 0.5 or 0.4. You should not take on that FDI variable again, because it already represent. So as a thumb rule, in case of time series analysis, you use that if the two variable with all the variable, that factor loading, that multipolarity should be less than 0.30. All the variable which the multipolarity is less than 30, all these variable you should take into the model, and which variable like your correlation. You see, actually what you do when you are very simple, like solution I'm giving, when you are taking including variables, you do one simple correlation matrix analysis. If in any variable between the two variable has a correlation more than 0.30, like closing your eyes, please drop that variables. That variable cannot act as a control variable. Getting my point?
Yes, sir. Yes, sir. Sir, can you please also show in the e-views that how do we run the control variable? Like, I know about the dependent and the independent ones.
Hey, see, listen, control variable is like a independent variables. Okay.
Okay.
We call it control variable because that in our research problem that doesn't have any importance. But
Fine.
that variable we include because that has some significance is there. And if you not include that, that explaining power of the model does not increases. Okay.
Fine,
like your R-square value, adjusted R-square value does not increases. Like if I'm doing one like Keynes, if I'm testing Keynes psychological law of consumption function for Jammu and Kashmir, and if I'm only taking that consumption and income, so I will not get R square adjusted R square or R square big close to 8 or 9. If I'll tell 10, 15 numbers which are really affect that I told in the morning, that which are like health expenditure, education expenditure, demonstration effect, your wealth, and your depend upon your interest rate, religion, Christian, so many things.
Okay, sir.
If I'll take, these are all control variable. When I'll include all these, your model will be more realistic model and your R square will increase. That doesn't mean that I should include two variables which have high correlations. I have given that variables have a very less correlation, and that should be the thumb rule called 0.30. That means
fine, sir.
30%.
So then it should be like the control variables are later on be given the name of control. Initially, they are the independent variables.
Yeah, in that empirical model, you can write these are the variables I'm taking as a control variables to increase my explanatory power of my model.
Okay, sir. Okay. Thank you, sir.
Yes. Next question, please. Next question. Do you have any?
Sir.
Yes.
That for VAR wall, should we test the stationarity?
For?
VAR, vector auto-regression model.
See, the vector auto-regression.
Because it is a theoretical.
Yeah. For VAR also you need to test stationarity.
Although it is theoretical?
Theoretical the meaning of theoretical means that, like, when you do any regressions, behind regression we are trying to establish one theory. Like I am given the Keynes psychological law of consumption function, or determinant of health expenditure, or determinant of like enrollment of education in Odisha, or determinant of growth, or anything you are trying to understand, and behind that one theoretical foundation is there. When you write paper, you write what is the theoretical foundation of paper. On the basis of theoretical foundation, you define your dependent independent variable. But VAR, you don't do like that. VAR, what you do that? Like nowadays, big data analysis or artificial intelligence, what we take a set of the data. From the data, we first run a VAR structure, and we fix the lag length criteria, proper lag length criteria. From that lag length criteria, we try to derive the theory. It's a reverse way. Ultimately, we are giving the theory, but from data, we are giving the theory. But in case of regression, from theory, we are trying to tell whether it is matching the theory or it is going opposite the theory. That is the meaning of our theoretical model. So it has nothing with the stationary. Both the places you need to run the stationary.
Okay, sir. Okay. Thank you, sir.
Sir, I have another question.
Yes, please. You are welcome.
Sir, is it okay to write a paper without considering the control variables?
Yeah, you can. Like control variable, like if you have unknowingly, if you have taken all these variables which are relevant, you don't need any control variable. Na?
Okay, sir. Okay.
Could you please have insight on policy analysis level, sir? How to utilize it?
Like
It's important because there are several policies in the India. How, as a researcher, we can work in that particular domain?
Yeah. For example, I have taught you that causality analysis. In the causality analysis, I have two variables. First, with the bivariate techniques, I have used that FDI as well as growth of GDP. So if and from there, I got that result that FDI is causing growth. So as a economist or I should give, like, this is a macroeconomic data. I should tell to the government that, see, there is a causality, cause and effect exists between FDI and growth, and this is the data, and this is the techniques I'm used, and this is the result I'm getting. So if government will do conducive policy and attract more FDI instead of like policy and interest rate and infrastructure, everything, what will happen? The growth will increase. So this is the policy from my research. I'll tell government, please give all this conducive environment to the foreigners, and they will come and they will establish their MNC, they will invest, and the growth will increase. This is the policy I'm giving. But for example, other research you are doing, for example, determinant of health expenditures. If I'll tell, if there is a one point will coming that awareness, if will increase awareness among the poor people, the village poor peoples, then your performance of health will increase. So for increasing awareness, you have to send ASA workers there. You have to do the advertisement in the table, radio, TV, social media. Then only so awareness become an important element for performance of the good health conditions. These are the solution, and this solution only you can give from your interpretation for a result. So then you will have a better result, and people can expect it. And your policy solution should always driven from your analysis. You cannot isolation. You can tell anything. Whatever your like empirical analysis is telling you, even if there is a one established law is there, and from your discussion you are getting some contradictory result, you can tell the same result. There are a lot of research. Some group of people telling FDA has a negative impact. Some people are telling FDA has a positive impact on growth, and they are from empirical analysis, they are wrong. So they are the way of approaching is right. They are telling why it is a negative effect. Some group of telling why it's a positive effect, and they are logically establishing that, logically proving that same thing is possible. This is what is research. That's why Mamata Banerjee is not allowing in that Bengal FDI, and is Naveen Patnaik is favor of FDI. So it is different, like different like empirical exercise is giving different result. Any other question, please? Feedback form is available. I think Chitta sir will tell how feedback form is available.
Excuse me, sir.
Yes. Prakash. Yes, Prakash, tell me.
Sir, I am Sushant, sir, but my name is Prakash is written there.
Yeah, okay, Sushant, tell me.
So my question is, sir, in my thesis, I have taken step-wise regression to select the variables whether which are affecting my FDA as a dependent variable, sir.
Yeah.
So there I found that many variables affecting FDA in step-wise regression. I got 5 variables out of 11 variables, sir.
So you have done forward stepwise regression or backward stepwise regression?
Sir, forward, sir. Forward, sir.
Okay.
Sir, but when I regressed that ARTL model, because some are mixed in integrated, some are variable in level and some are in third difference.
Yes, please.
There I found that many variables are not individual, not affecting FDA, sir. They are not significantly individual, sir.
See, that problem what you have done is different. See, in the regression, stepwise regression, you have done impact analysis. And in Airedale, it shows the long run or short run correlation. The set of problem is different. I'm trying to understand. These are not same. The impact and the core, that relationship is different. Okay.
Yes, sir.
So that's why you are getting different results. So it is advised in a very good papers, you should not run like impact or causality analysis as well as your Airedale model. If you are using regressions, it is fine. If you and that will get there, you will get a different result. And when you are doing Airedale model, you will get a different result. You should not be worried about why the different result is coming, because there is an impact analysis, and here is you have a short run and long run relationship. Because short run you have a different story, long run you have a different story. Because short run, long run you will find some variable they are co-integrating, but in short run you will find some variable there that they have positive. You are getting this type of result, na? In some variable which are stepwise significant is not significant, you are not getting the significant relationship. That is obvious. So you are getting more in short run or in long run?
Sir, in short run, they are getting.
I understand your problem. I understand. Basically, we face the problem. In short run, what will happen? What will get in there? All the variable will not get significant, and which is obvious. There is nothing wrong in that, because something which in regression you are taking as a whole stepwise. But in a short run, what we are doing, we are only trying to correcting the short run behavior. It is not entire long run period. That's why there you are getting some set of relationship, and here you are getting either opposite or some insignificant relations. Those who understand empirical analysis, they will tell yes, is correct, because it may be happening that FDI and growth has a significant relation, that has a relation in the stepwise regulation, but when you come to short run, it will don't have any relationship in short run. Long run it will have a relation, but according to you, if you see the what is your coefficient of ECM?
Sir, the minus 0 point something, sir.
What is minus 0 point, how much? That is important, na?
0.03, sir.
0.03 means it is yearly data or quarterly data?
Sir, yearly, sir, up to 1982 up to
Yeah,
2020.
so yearly data means in that short run, it takes 3 hours, 3 years to catch the equilibrium. That is the meaning. So 0.030 means 3 years. So in the 3 years, there is a disturbance. So how you expect the short run and that stepwise regulation will have same result? Because that is data as a whole, it is only short run adjustment behavior is depicting. So it is a different set of problem. So obviously this result will be different. Getting my point?
Yes, sir.
I hope before doing that, your stationarity and all other tests you have checked it.
Yes, sir.
Stationarity, multipolarity, autocorrelations, normality, everything, all the robustness test you have done before doing that.
Yes, sir.
You have done? But if I have not done all this, like your normality, autocorrelation, heteroscedasticity, multipolarity, all the tests you do that, then you do, if I've done all the tests and got the correct result, and you are getting this type of result, is right. If I've not done all the tests and you have done, there's something is there, you check it and then you correct it, and then again you run.
Okay, sir. Okay, thank you, sir. God bless you. Thank you, sir.
Thank you.
So I'm just trying to understand that pairwise grandeur causality test. So if the F statistic is more than probability, then we'll reject the null. So if the null is GRGDP doesn't grandeur causes FDI, then I will conclude that GRGDP grandeur causes FDI. Is it?
See, Tanushree, you need to understand what is the concept. In causality also, there is a null hypothesis, there is alternative hypothesis there. In null hypothesis, we are taking, there is no, because, just 1 minute. Tanushree, you need to understand, because in null hypothesis, I told always null hypothesis, what you take? You take actually false hypothesis. That you are trying to establish the causality. So in null hypothesis, what will write? There is no causality between FDI does not cause Gandhar causality. That is null hypothesis. An alternative hypothesis that FDI cause Gandhar causality. So when your calculated value is less than tabulated value, so you have to expect that value. If the calculated value is greater than tabulated value, you have to reject a null hypothesis. Then your alternative hypothesis will be true.
In the table, F statistics means it's the calculated value and probability is the critical value.
Yes, it's a calculated value and it has tabulated value. And when you are experience from probability value, you understand. If it's less than 0.05 or maximum 0.010, then it is significant. If it's greater than 0.10, then it is not significant.
Okay, sir. Thank you so much, sir.
Okay. Next, please. I think the chat box also.
So yeah, I think we are done.
Yes, sir.
Thank you, Dr. Pabitra, for the painstaking analysis and taking all questions from the participants. If anybody has anything to ask, you can still share on the chat box. And some people are asking for feedback link. There is no feedback link. Please don't worry for that. Don't expect any certificate. So the participation and your knowledge gaining may be construed as your certification. So whenever we participate, we always expect that we should get something. And here the only expectation is knowledge gain, expertise gain. If that is achieved, we are done. And it will be nice if one or two participants give any feedback please raise hand if somebody is willing to say something regarding the conduct of this e-workshop. That will really help us, those participants who participated from beginning to the end can raise hands. Oh yeah, so many nice observations and compliments are coming for our esteemed speaker. That is really pleasing us.
No, sir.
So that is the feedback we think. If still, if somebody intends to say something, Labani, Prasad, Deepak, Kumar, these people have raised hand. Yes, Labani. Please
Sir, I
unmute
need the
yourself
feedback.
and
Sir, I need the
speak in
feedback how
brief.
I should improve. I will be happy that somebody can tell what is my demerit, how I to improve. I don't need any praise because
Exactly.
so I have tried my best within my
Labani, are you willing to speak? So please unmute yourself. Rupansi, please unmute
Yes,
and
sir.
speak in brief. Yes.
Sir, it
Welcome.
was a wonderful session. Actually, we got so much insight from this session on time series data. And I'll be waiting for the panel data analysis if you will be teaching us in the near future. So can we expect any workshop on panel data? Sir, am I audible to you?
You are asking me or you Chitta sir?
Yeah. So like Rupansi. Okay. So some hands were raised, but now they're not visible to me, whether they are online or not. So we'll go for the formal vote of thanks. Anybody who wants to, yes, Prakash, you'll get the recording. You see, we have a YouTube channel where it will be uploaded with due permission from the speaker. So that link will be shared to all of you. I hope all of you are in the WhatsApp group of Moga Shiksha Parishad. And that the name of the group is Moga Shiksha Events. If you are not there, then you simply make a request to Chinmay, are you there?
Yes, sir.
So what is the email ID of Moga Trust?
Exactly, I have not remembered.
Otherwise, you can
We'll check.
mail to this.
Yes,
Those
sir.
who
Yes.
are not in the group, those who are not in the group, they can share, that they can make a request to this email ID which I just posted. SV, sorry, one L is, I'm writing again. SV Loka Sansad at gmail.com. Just drop a request to this one. The link will be provided to you. And Chinmoy, if possible, please share the WhatsApp link,
Okay, sure, sir.
if possible. Okay. So it is up to you, Chinmoy. Is Gangadhar Das sir present?
Gangadhar, sir, are you present here?
I think he's not here.
Okay. Then
Okay,
I would
you offer
like
the
to.
vote of thanks, Chinmoy. No worry.
Okay. Okay, sure, sir. On behalf of Moga Shiksha Parishad, I would like to express my heartfelt thanks to the resource person or speaker, Dr. Pabitra Kumar Jena, sir. He has enlightened us with different types of examples for this particular data analysis. He has given the examples of layman and also mathematical way and also econometrical way. So, and I hope all the participants present here have understood this particular data analysis session in a very insight way. So I express my heartfelt thanks to the organizer also, and also Professor Chittaranjan Naik for his inaugural address and for conducting this workshop. And I also express my heartfelt thanks to the Minakatan sir, who is the convener of this Moga Shiksha Parishad, and also all the organizing team of this Moga Shiksha Parishad, and not the least all the participants uh, today, those who have actively participated and also those who have passively participated in this particular e-workshop, national e-workshop. We all are thankful to them. Thank you so much, all the participants, and also Dr. Pabitra Kumar sir.
Thank you.
Thank you.
Thank you. Thank you for your time.
Yeah, some people are suggesting for a session on panel data, and they are suggesting the name of Dr. Pabitra to find time. That will be intimated to you. We are taking note of it. Please note that all first Sunday, 11 a.m. is fixed for Moga Shiksha Parishad activity. That will be done. So we will meet again in the month of August. That will be the first Sunday at 11 a.m. But what will be the event, that is not known to us. That may be a seminar, that may be a workshop, that may be anything. But an event will be there. So thank you for being with us. Once again, I, on behalf of the organization, offer my formal vote of thanks to dear colleague Dr. Pabitra and Dr. Chinmay, and the person who is behind this event but not present here because of his personal engagement. We are missing him, Professor Minoketan Behera, who was instrumental to conceptualize and find the resource person for us. So he also deserves a sense of applaud from all of us. So thank you, Minoketan. I think you will see this video recording when it is posted on YouTube. So now let us, Chinmay, is there anybody for Shanti Path? Or let me do this. Okay. Om Sarve Bhavantu Sukhinah, Sarve Santu Niramaya, Sarve Bhadrani Pashyantu, Ma Kaschit Dukkha Bhag Bhave. Om Shanti, Shanti, Shanti. Thank you, everybody. Let us call it a day. So we'll meet again. Thank you, Pabitra.